Good morning. Welcome to All This Math. This is Professor Parker, and today we're going to talk about how to solve an equation. Now, this isn't just any equation. Look on this board. Just take a minute and just soak that in. All right? Now, this is one of them crazy looking equations. There's a lot going on with this equation. This is kind of complex. But what I'm going to show you is how we can simplify this equation, break it down step by step, right? One step at a time, and then end up with a single answer. All right? And now this method that I'm going to show you, you can apply in any situation, all right? In any equation that you see, no matter how wide it is or how narrow it might be. All right, so first, look at the equation, read it, understand what it's saying to you. You have 13 minus the quantity. Whenever you see terms inside of parentheses, that's called a quantity. All right? So we don't say 13 minus parentheses, 2c. No, we don't do all that. All right? But you have to acknowledge the parentheses, okay? Because this is also not 13 minus 2c plus 2. That would be something different. So you want to say 13 minus the quantity of 2c plus 2 is equal to 2 times the quantity of c plus 2 plus 3c. So first, understand what you're trying to solve for. Look for the letter in the problem. This letter C right here, this letter C right here, and this letter C right here. We're trying to figure out what number would go in the place of C to make this a true statement, meaning the left side of the equation would equal the right side of the equation. All right. First thing I want to do when I do these problems is I want to get rid of all parentheses. I want to get rid of the parentheses. All right. So put that in your notes. First step, get rid of the parentheses in this kind of problem. If there were fractions in this problem, I would get rid of the fractions too, but there are no fractions here. We're dealing with integers, and yeah, we're dealing with integers, everything. So we don't got to worry about getting rid of the fractions. We do have to worry about getting rid of the parentheses. Now, how do you do it? You always look at what number is in front of the parentheses. So here, this is a minus sign. You might say, well, Professor Parker, there's no number right there. There's a 13 right here, but understand, this 13 is not being multiplied by this quantity. The number, the invisible number after the minus sign is being multiplied by this quantity. And what number might that be? A 1. So there's an invisible 1 in front of that quantity. All right? Over here, the number is not invisible. It's a positive 2, and you see it. It's right there. All right? But first thing you're going to do, you're going to distribute the numbers that are right next to the parentheses into everything inside the parentheses. That's going to be your first step. You're not going to mess with nothing else. All right? First thing, that's how we get rid of the parentheses. So we bring the 13 down because we don't mess with the 13 yet. Not yet. It's not its time. We're going to get to the 13, but not yet. You do negative 1 times 2c, which is minus 2c. You do negative 1 times 2, which is minus 2. Then slide over. You're going to do 2 times c, which is 2c. And 2 times 2, which is 4. And then you're going to do plus 3c. All right? So now the parentheses are gone. Parentheses are gone. All right? And that's an important step in our process. Now, the next thing that we're going to do, and I kind of want you to understand that you don't have to go in this order, but this is just my way of doing things. What I like to do is I like to transpose. I like to reorganize my problems. I like to move all the variables to the left side and then all the constant terms to the right side. Now, what is a constant term? A constant term is a number that's just a number. There's no variable next to it. There's no letter next to it. It's just a number. 13 is a constant term. Negative 2 is a constant term. 4 is a constant term, right? So I want all my constant terms on the right-hand side of the problem. I want all my variables on the left-hand side of the problem. So when I move them around, that's called transposing. Transposing. That's what that's called. That's called transposing. So what I'm going to do is I need to move. What do I need to move? I need to move this 2c right here over there. And I need to move this 3c right here over there too. And then I need to move this 13 over here and this -2 over here. And I just basically want to reorganize the problem. Now, what's the point of me doing that? Once I reorganize the problem, then I can do something called combine like terms. Some textbooks call it collecting like terms. Either way you say it, it still means that you're consolidating all the constant terms or all the variables into one individual term on their respective sides of the equation. So, but I got to rewrite it first. So now I move this 2c over here. That 2c came over here. Oh, I forgot to do something. Whenever you transpose, whenever you move from one side of the equation to the other, the sign changes. The sign changes. Do not forget that. The sign changes. So this was a positive 2c. When it moves over, it becomes negative 2c. You already had a negative 2c over here, so you just bring that down. Write it over again. This 3c also moves over to the left side, right? It switched sides. It becomes a negative 3c. So you have minus 3c. So now I got all my c's in one place on the left side of the equation. Then I bring the equal sign down. I already had a 4 over here. Keep that 4 over there. This 13 moves over to the right side. That positive 13 turns into a negative 13. This -2 moves over to the right side. That -2 turns into a positive 2. All right, so now I got my problem organized. Now it's organized. I got rid of my parentheses, and then I transposed, and I got my problem organized. I got all my C terms over here, and I got all my constant terms over here. Now I can combine like terms. So I can do my addition and subtraction with everything on the left side, and I'll also do my addition and subtraction with everything on the right side. This is one way to solve this equation. This is not the only way, but this is one way. And I think this is a very efficient and effective way. All right. So now I do -2 minus 2, which is -4, minus 3, which is -7. So now I have -7c. So all three of these terms combined together result in just -7c. That's how many c's it is. -2 c's, minus 2 more c's, minus 3 c's gives us -7c, right? Now on the right-hand side, I got to do 4 minus 13 plus 2. So 4 minus 13 is going to give me -9. And then -9 plus 2 is going to give me -7. So check this out for a minute. Look at how long this problem was from the rip. Now look at how short this problem is now. All we did was go through the problem step by step. And if you were a little intimidated because you saw the problem on the board and you said, oh my God, I can't do this. This is why I hate math, because I hate problems that look like that. Look what we just did. We went through step by step and we made it shorter. And whenever you see a problem like this, you too can do the same thing. Just follow the steps and do the math correctly. Follow the steps, do the math correctly. So now we have -7c equals -7. All I want to do is get c by itself. That was the ultimate goal. Get c by itself. So I got to get rid of what? -7. But how do I get rid of it? How do you get rid of -7? You do the opposite operation from what -7 is doing. -7 is multiplying by c, because that's what -7c means. -7 times c. That's what -7c means. So the opposite of multiplying, we know, is division. So we're going to divide by -7 on the left side. But if I divide on the left side, I also got to divide on the right side. So boom, divide that by -7. Cross that out. These become 1s. 1c divided by 1 is just c. On the right side, -7 divided by -7. Is that +1 or is that -1? It's +1, because whenever you divide a negative by a negative, your answer is always positive. Just like with multiplication. When you multiply a negative times a negative, the answer is always positive. So this is equal to 1, right? Now, I wouldn't stop there. What I highly recommend for everybody to do, anybody watching this video, always check your work. Always check your work, no matter what. Because that way you don't got to worry about waiting for the teacher to validate you and tell you that your answer's right. You can know your answer's right. You can let the teacher know your answer's right. You never have to wait for anybody else to validate what you're doing if you check your work. And with many problems in mathematics, you have the ability to check your work. So you can be confident already. So how do we check our work? We think that C is equal to 1. So that means I should be able to go back into the original equation, substitute 1 for C wherever I see a C at. Here, here, and here. And then calculate the left side, calculate the right side, and they should be two numbers that equal each other. So check this out. I'm going to do this mentally. 2 times 1 is 2. 2 plus 2 is 4. 13. Now, we're also following order of operations. The triple O thing. Order of operations. We always follow order of operations when we're checking our work, when we solve an equation. So now we're doing 13 minus 4, which is 9. So the left side is equal to 9 if C is 1. Now we got to make sure the right side equals 9 when C is 1. So now I do this. I do 1 plus 2, which is 3. Then I do 3 times 2, which gives me 6. Then right here I do 3 times 1, which is 3. And what's 6 plus 3? Also 9. So if this value for C gives me a true statement, that means that this value is correct. So don't just go through your problems, solve for the variable, and just be like, all right, I'm done. I'm trying to tell you, always check your work. Do yourself a favor, check your work. Plus, when you're checking your work, it gives you a chance to really reinforce some of those basic skills that you might have forgot. Like, you know, it just helps to like practice the order of operations. It just helps to multiply and divide numbers. It just helps. Every little bit helps. So here we started out with a complex equation, multiple steps. We solved it. We went back and we checked it as well. So hope you enjoyed this. I hope this was helpful. Please like the video. Please tell other people about it. Share it. You know, text it to people, whatever. You know, put it on social media, whatever you want to do. Please recommend the page, the All This Math YouTube channel. Have people subscribe. If you haven't subscribed already, please subscribe and tell a friend to tell a friend. And also remember that there's all this math all around you.